Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 7, Got 6, Module 5. And this is my first video with my new mic, so hopefully this sounds a lot better than the prior videos. And we're going to improve from there. So let's see where this takes us. Lesson 7, Distance on the Coordinate Plane. Determine the lengths of the given line segments by determining the distance between the two endpoints. So the first thing we have to do is write down the first endpoint, which is A, and the second point, which is D. So this is a line segment AB, where A is an end and B is the other end. So I need to know where A is, and A is right here, and that is left 2 and up 1, 2, 3, 4, 5, 6, 7, 8. So that is -2, 8. The other end, which is B, is over here. So line segment AB is right here. And B is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is the point 9 on the x-axis, comma, 1, 2, 3, 4, 5, 6, 7, 8. And 8 on the y-axis. And the distance is how far away the x's and the y's are. Well, 8 and 8 are the same. That means that AB is horizontal, and they're both at an altitude or a height of 8 units up on the y-axis. So the lengths, it's a horizontal line, so we need to determine the distance from 9 and -2. So from -2 to 0 is 2, and from 0 to 9 is 9. And 9 plus 2 is 11. So this is 11 units. Okay, and the proof is, well, how are we going to prove this? Let's see. Okay, so we're going to do absolute values because distance can't be negative. So we want to ask ourselves, how far is A from the y-axis? And it's left 2, so we'd say the absolute value of -2 plus the absolute value of the distance B is from the y-axis, so that's the x value, 9. So the absolute value of -2 plus the absolute value of 9 is the same as 2 plus 9, which equals 11. Okay, next point, BC. So B is right here. So that's our starting point, so that's our end point on the other, so I'm not going to count again. I know that B is at the point 9, 8. So how about I label that here, 9, 8, and we already know that A is -2, 8. So then C is right here, so that's over 9 because X is our first value. So just to save time counting, I now know C is 9 units to the right, but then C is only up 2. So now the difference is in my vertical differences, my Y values, my X values are the same. So from 2 to 8 is a distance of 6 units. Okay. In order to determine how far that is, okay, so when we're on the same side of the x-axis, such as this, the 2 points are both positive, then we subtract. So we subtract 8 minus 2, or the absolute value of 8 minus the absolute value of 2, which is 8 minus 2, which is 6. Now, when we were on opposite sides, when one is negative and one is positive, we want to add the absolute values. When we're on the same side of the axes, y or x, we want to subtract. Okay, so CD, again, point C is right here. C was 9, 2, and I'm just going to label this so I don't have to keep counting. So C was 9, 2, that's one endpoint. And then D is 9, -1, 2, 3, 4, 5. So this is 9, -5. So notice the X values are both 9, so we're not going to have anything to do with that. We just want to measure the vertical difference. One is positive, one is negative, so we want to take the absolute value of 2 plus the absolute value of -5, which is 2 plus 5, which is 7. So this is 7 units. Okay, continuing on. BD. I know B is 9, 8 from this one. B started here, so that's this point. So B is 9, 8. And D was the end point of my last one, which is right here, 9, -5. Okay, the 9's are the same, so I'm going to focus on the Y value. One's positive and one is negative. So I'm going to take the absolute value of 8, and I'm going to add the absolute value of -5. And that's going to give me 8 plus 5, or 13. So that is 13 units. Okay. Next one is DE. Well, D is right here, -9, -5. And we have not done E yet, but it's down 5. So I know my Y value is -5, and my X value is -2. So it's -2, -5. And since they're both negative, they're both on the same side of the X-axis. Oh, I'm sorry, the -5 and the -5 are the same. 9 and -2 are opposite signs. So I'm going to add the absolute value of 9 plus the absolute value of -2, which equals 9 plus 2, which equals 11. So this is 11 units. EF. E is here, F is here. F is the point -2, over 2, down 2, -2. So E is -2, -5. And F is -2, -2. The X's are the same, so I'm going to focus on the distance from -5 to -2. They're both negative, so we're going to subtract the absolute value of -5 minus the absolute value of -2 equals 5 minus 2, which is 3 units. And keep in mind, if this confuses you, you should get in the habit of understanding this or practice until you do understand it. But if you want to check your answer, EF is right here, you can just go down and count. There are 3 squares. Okay, now FG. So F is here, that's -2, -2. G was not done yet, so that's -2, something. So I'm going to label G -2, and then up 1, 2, 3, 4, 5, 6. -2, 6. The X's are the same, so I'm going to look at the Y's. This Y is negative, this Y is positive, so I'm going to add the absolute values. So the absolute value of -2 plus the absolute value of 6 equals 2 plus 6, which equals 8. So that is 8 units. Okay, now EG. Well, E is here. It's -2, -5. And G is right here, and that's -2, 6. The X's are the same, the Y's are different, they're opposite signs, so we're going to add the absolute value of -5 plus the absolute value of 6 equals 5 plus 6, which is 11. So this is 11 units. Okay. GA. One endpoint is G, which is -2, 6. And A is right above it here, -2, 8. The -2's, the X values are the same, but the Y's are different. They're both positive, so we're going to subtract. So it's going to be the absolute value of 8 minus the absolute value of 6, which equals 8 minus 6, which equals 2. So that is 2 units. FA. F is here, it's -2, -2. A is -2, 8. The X's are the same, so I focus on the Y's. One's positive, one's negative, so we're going to add the absolute value of -2 plus the absolute value of 8 equals 2 plus 8, which is 10. So this is 10 units. finally, EA. E is -2, -5. A is -2, 8. The x's are the same, so I'm not going to do anything with those. Y is -5, y is 8. They're opposites. We're going to add the absolute value of -5 plus the absolute value of 8 equals 5 plus 8, which is 13. Okay, so EA is 13. Okay, so this is the exercise on what we just did. So now it's your turn to give it a shot. Fill in this table, pause the video, come back and see if what I filled in is the same as what you got. Okay, so the first thing I'm going to do is I'm going to label my diagram. So I'm going to label A, and then I can just use those values. So here's my origin, -1, -2, -3, 4, 5, 6, 7, 8, 9. So this is -9. And this is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. B is -2, 3. C, I'm going to go alphabetical order. 1, 2, 3, 4, 5, 6, 7, 8. Down 1, 2, 3, 4. That is the point 8, comma, -4. D is the point 8, -4, 5, 6, 7, 8, 9. This is 8, -9. E is -2, -9. And F is -9, -9. G is -9, -4. And H is -2, -4. And I is -2, 0. It is right on the x-axis, so it's -2, 0. Okay, so I labeled all 9 points that they gave us. Now we just have to write in those points. So I'm going to start with BI. B is -2, 3. I'm just going to fill in all the B's first, since I started with B. Anywhere I see a B first, it's going to go in this column. Anytime I see a B second, it's going to go over here. So BH would be -2, 3 for my B. BE, this is -2, 3 because that's B. And then I look down further and I don't see any more B's. Okay, so now let's look at A, -9, 8. So A is -9, 8. A is -9, 8. See how the A is second here, so I put it in this column. And I'm looking for A's. I don't see any other A's. Okay, we did B. Now let's do C. Here's a C. C is 8, -4. So I'm going to put that over here. C is 8, -4. C is 8, -4. This C came first, and there's no other C's. D is the point 8, -9. Here's a D here, and it's second. 8, -9. No other D's. E is the next one. E is -2, -9. There's no other E's. F is -9, -9. That's here. I don't see any other F's. BI, BH, GH, HC. No AF here. Here's F. So F is -9, -9. G is -9, -4. Here's a G. Here's a G. And here's a G. H is -2, -4. That will go here and here and here. And then I is -2, 0. I missed a G here. G is -9, -4. Okay, so there's many different ways we can do this. I just decided to do it by letter instead and filled in the table. And now I'm going to go over and do my proofs. So my x's are the same. I've got 3 and I've got 0. They're both positive, so we add their absolute values. So the absolute value of 3, actually we subtract, minus the absolute value of 0 equals 3 plus or minus 0. Okay. Actually, I was right before. I'm thinking plus. Add them. 3 plus 0. And this one, BH, -2, -2, the x's are the same, so I'm going to figure the y's. One's positive and one is negative. So it's the absolute value of 3 plus the absolute value of -4, which equals 3 plus 4, which equals 7. And I'm going to plug the distances in this column. Okay. Actually, this could have been minus, but that's okay. Doesn't matter with 0. Plus or minus 0 is the same thing. -2 and -2 is the same, and I have a 3 and I have a -9. One's positive, one is negative, so you add them, and that's 3 plus 9, which is 12. -9, -2, -4, -4. I'm going to see what the distance is between my x's in this case. So it's -9 and -2. So when they're both negative, we subtract the absolute value of -9 minus the absolute value of -2 equals 9 minus 2, which is 7. In this one, the 4's are the same, so we're not going to do the y value, we're going to do the x's. So we have one negative and one positive, so we add the absolute value of -2 plus the absolute value of 8 equals 2 plus 8, which equals 10. So that's 10. Forgot to close my bracket on this one. Now we have -4. -4 is the same, so we're not going to do anything with the y values. They're on the same vertical line. I want to take -9 and 8 and find their distances. Since they're opposite signs, we are going to take their absolute values and add them. -9 plus the absolute value of 8 equals 9 plus 8, which equals 17. CD, the x's are the same. We want to focus on the y's. They're both negative, so we're going to subtract the absolute value of -9 minus the absolute value of -4 equals 9 minus 4, which equals 5. In this one, we're looking at the y's. They're the different numbers, and they're both negative, so we're going to add. So, or I'm sorry, subtract. So the absolute value of -9 minus the absolute value of -4 equals 9 minus 4, which equals 5. Okay, in this one, the x's are the same. We want to focus on the y values. One's -4 and one is 8. One's positive, one's negative, so we add their absolute values. The absolute value of -9 plus the absolute value, no, not -9, I'm sorry, the absolute value of -4 plus the absolute value of 8 equals 4 plus 8 equals 12. And then finally, the y values are different in this. They're opposite signs. We're going to add the absolute value of 8 plus the absolute value of -9, which equals 8 plus 9, which equals 17. And we have completed the table. Here's an extension exercise. For each problem below, write the coordinates of 2 points that are 5 units apart, with the segment connecting these points having the following characteristics. These segments are vertical. Now, if you go back and look at this, vertical means straight up and down. So this segment here, AG, is vertical. So what do we know about the x values of A and G? The x values are the same. The y values have to have the difference in the distance. So I want a segment that is vertical, means the x values are the same. So I want 2 points whose x values are the same, and it doesn't matter what you choose. You could choose 10, negative 10, 5, 3, it doesn't matter. I just need my x's to be the same. And then I need 2 points that are 5 units apart for my y. So I could choose 1 here and 6 here. From 1 to 6 is a distance of 5. There are infinitely many solutions to this. As long as your x's are the same and your y's are a difference of 5, then you've answered the question. Okay. B says the segment intersects the x-axis. Okay. In order for it to intersect the x-axis, so this is an axis, this is the x, this is the y. In order for a segment to intersect the x-axis, it has to be vertical. And if it's vertical, then we know its x values are the same. So I could just choose any value, 3, 3. Or I could make it negative 3, negative 3. It doesn't matter as long as this line is here. No matter where I move this line, it is intersecting the x-axis, and its distance, its length, never changes. So I want it to intersect the x-axis, and it didn't specify its length, so all I need to do is give it a value that is positive and a value that is negative. So if this was the point negative 3 comma negative 2, then this would be the point negative 3 comma 5 here. Okay, and obviously that wouldn't be drawn to scale. Negative 2 is closer, so it would be more like that. Okay? All right, so the next one. This segment intersects the y-axis. Okay, well, let me just do this again. So if we have a coordinate plane like this, this is the y-axis. So in order for a segment to intersect the y-axis, it must be horizontal. And that gives the y value the same value. So I just need to pick a y that is the same. Doesn't matter which one you choose. It intersects the y-axis, meaning one is positive and one is negative. Negative 2, positive 2. Okay. Now it says the segment is vertical and lies above the x-axis. So I'm going to get rid of this. Okay. And I'm going to draw a vertical line that is above the x-axis, a line segment that is above the x-axis that is vertical. So we know it's got the same x value. So I'd say negative 2 comma something, negative 2 comma something. So if it's vertical and lies above the x-axis, then the two y values have to both be positive. Okay? And that is the end of lesson 7. Go do your problem set.